Alternating current circuit. Okay, welcome today to another episode of King Solomon and David Pecosi on applied electricity. And today we're dealing with alternating current circuit. Alternating current circuit. What is the idea about alternating current circuit? Before we go on the slides to understand the idea of alternating current circuit or the meaning of alternating current circuit, I would like us to do something over here and understand the difference in the AC circuit and a DC circuit. Now, AC circuit is very simple, and DC circuit is also very simple. How do we understand the two of them? Now, the DC circuit, so assuming we have a voltage across a time period, the DC circuit has no, when you have a DC waveform, there is no alternating in a DC waveform. So that is to say there is no polarity as in the plus or minus peak in a DC waveform. No. But when it comes to an AC waveform, there is a polarity. So there is a plus and there is a minus peak voltages or peak currents. So now realize that we're having a sinusoidal curve, you can be having a square wave and all these kind of things. So before we go deep into an AC very well, let's look at the slide and look at the definition of an AC.
So alternating current circuits are circuits with currents and voltages which are time varying. So these are some terminologies in AC circuit. We have the amplitude, which is the maximum deviation of the function from its center position. We have the cycle, which is the repeating portion of a function. We have the period, which is the duration of a function, and frequency, which is the inverse of a period.
Okay, now from the slide, we understood that there are many ways you can have an AC waveform, and one of them is what? The sinusoidal wave. So realize that there's an alternating here, so there's a peak here. Sorry, this is minus, so their polarity changes, so they are alternating. So this is a sinusoidal wave. This is also a square wave. So a positive peak value, you can also have the negative peak value. This is also a triangular wave. You can have the positive, let's say it's current. So you can have the positive peak current, you can have also the polarity of the negative peak current. But now, this is one example of a triangular wave. So this triangular wave actually is what? A right angled triangular wave. So this actually here is a right angled triangular wave. This one, you can either assume it, the sides here and sides here are equal, then it can an isosceles triangular wave. But for the sake of this course, most of the times we go on with the some more examples on the right angle triangular wave. Now, we can also have sections in a triangular wave or a waveform that will combine either the sine wave and the square wave, or either the sine wave and the triangular wave. So you can have a waveform of this nature as, let's say, I, that is the current, so the function, and let's say this is time. So we can have something of this nature, a sinusoidal wave, and the next portion becomes a triangular wave. So this can be a waveform for a particular problem of a particular situation. You can have this as a waveform. Now, let's assume that this is our waveform, and we want to understand the parameters of waveform. So before I come here to explain the parameters of the waveform, let's look at the slides and look at the terminologies in the waveform. Okay, so from the slides, the terminologies we had of the waveform, we had one, the peak or the amplitude. We also have the cycle, the meaning of the cycle. You also have the meaning of period, and we also have the meaning of frequency. You can also have average value, which will be my next topic or the next lesson after this video. So the average value, I won't talk about in this video. I'll talk about it as a fresh topic. So now, how do we find all of these using this as our waveform? So using this diagram as our waveform. Now, let's number here as A. Let's say here is B. Let's say this point is C. So that the waveform continues. So we have another this and another triangle. So it continues. So it's more or less like these two shapes repeating itself over and over. So now, if you have this point, and let's say this is our Vm. Now, how do we identify the peak or the amplitude value, the cycle, the period, or the frequency? So now, one, the peak for this, the peak or amplitude for this waveform will obviously be what? The Vm. Yeah, most of the times the peak varies. Let me see, the peak varies with respect to the polarity. That is not necessarily the absolute value. The absolute value will always be the same. But the value with respect to its polarity, that is the direction, sometimes changes. This is what I mean. So if I have, this one is a waveform or AC current waveform with only a positive peak value. But you can have others like this, which will have a positive peak value as maybe plus Vm, and this one will be a negative peak value as negative Vm. But the absolute value will still be the same. It doesn't matter whether it's negative or positive. The absolute value is still the same. So when it comes to the absolute value of the peak value, it has nothing. But sometimes the polarity, that is the alternate, so the polarity changes. It's not straight. Okay, so now in this case, this is the peak value. Sorry, this is too long. It has to also be at the same length as here. So they all be at the same. So that will be the peak value for this waveform. And the second system, we want to check the cycle. So the cycle becomes the repeating function that we are dealing with. So if we have, so with this diagram, for instance, we have both a sinusoidal function and we have a triangular wave function. So now what happens is that the repeating of this is both the sinusoidal function and the triangular function. So now the cycle will start from, or the cycle span for this waveform will start from A to C. So this is the cycle span. So the whole of this A to C, because we realize that the same sinusoidal and the triangular will still repeat itself in the other form. So now if we have an example like this function, let's say v of t to t, and we're having something like only a sinusoidal, then the cycle ends here. So if you have maybe 0, 1, 2, then this maybe 3, 4, 5. This is a complete cycle. I don't know, this is a complete cycle. It's a complete cycle because it starts from here to here. So now you can cut the whole of this and you join it up to this place. It makes a complete shape, a complete cycle. So now the cycle span for this particular diagram or waveform will be from 0 to 2. And this will be the cycle span. Okay, because the main reason is that because of that, we alternate. Yes, so this one, this is the peak value, here to this is the peak value. If you add the two of them to the absolute value is still the same as the peak value. So this is the full cycle, one cycle. Okay. So now, if you understand this very well, then the cycle span, because that's the repeating. So you realize that when I do this one, and the same thing starting from this point, it started from this point, I repeated again. Starting from this point, I repeated. So the complete is the cycle. So the repeating function becomes the cycle. Okay. So now the third one is the period. Now what is the period? The period is simply the duration of a cycle. The duration of a cycle. So this is the time So now, the period here is from, when you take this waveform, this is our cycle. Our cycle is spanning from A to C. That is our cycle span. So the period is what? AC. So the period is represented most of the times by T. So now the period for this function, what do what? What will you see? That is from here to here. That will be the period. So if I have the same way, if I have a sinusoidal function, I have 0, 1, 2, 3, 4, 5, and about. From here, my period, which is T, will be equal to 2. Because this is a complete cycle. So it ends on what? The time, to the duration for the complete cycle. And the last one, which is frequency. So frequency is simple. Frequency is simple there. Simply the inverse of a period. So the inverse of a period is the frequency. So anytime I want to find frequency, it is 1 over capital T. That is the period. So if you know the period and want to find the frequency, then it's 1 over the period. And I think this will serve as a good start on introduction for us to understand what alternating current circuit is. We meet within the next video and we'll go deep and talk about finding the average value when you are given a current circuit, an alternating current circuit diagram, and also to the root mean square value. Bye bye. Have a nice day.